So, glowing petunias, huh? Pretty wild stuff. It's not your average flower, that's for sure. You don't see plants lighting up every day.
Nope, not exactly something you run into at the garden center.
No kidding. That article, the one you sent about the person who bought one, it really grabbed my attention too, They really went down the rabbit hole with it. Like, where did this even come from?
Yeah, I mean, it's a glowing flower. You got to know more, right?
Exactly. But it turns out there's this whole world of science and history behind it. It's way more than just like, ooh, a cool glowing plant.
Oh, yeah, definitely. This simple little flower, it's like a window into, well, all sorts of fascinating stuff.
Okay, so let's start with the basics, right? Bioluminescence. We all know about fireflies and maybe those jellyfish that light up. But I get the feeling it's way more common than we think.
It is. It's everywhere in the ocean, especially. But you find it on land, too. Bugs, fungi, even worms.
Wow. Okay, so we're not talking about like those glow-in-the-dark toys here. This is something totally different, right?
Totally. This is light that living things are, like, actively creating. It's all about chemical reactions.
Okay, now that's what gets me. How does that even work? What's happening inside these things to make them light up?
So imagine, like, a fuel. Scientists call it luciferin, then you need oxygen, of course. And the magic ingredient, this is the kicker, it's called luciferase.
Luciferase, okay.
Yeah, it's like a spark. It helps the oxygen, the luciferin react, and boom, energy's released. And guess what? That energy, it comes out as light.
So it's like tiny fireworks going off inside them.
Exactly. Little explosions of light. And get this, evolution has come up with a ton of reasons to use bioluminescence.
Oh, I bet. Like what? I'm thinking camouflage, maybe?
Camouflage, yep. But also attracting mates. Think fireflies blinking, or deep-sea anglerfish. They have this glowing lure to, like, draw in prey in the dark. It's amazing.
Wow, so many uses. It's like every glowing creature has its own little story, right?
Absolutely. And some use it as defense, too. Like some squids, they squirt glowing ink to confuse predators. Wild stuff.
Wow. Okay, see, this is what I love. Okay, let's shift gears a bit. Glowing fungi, they've been around forever, right?
Oh, yeah. We're talking like ancient times, Aristotle, Pliny the Elder. Those guys, they wrote about glowing fungi.
So for a long time, they were a total mystery. Like, how did they even work?
Oh, for sure. I mean, they knew fungi glow, but the how, and that was the big question. And did all fungi glow the same way? Lots of detective work there.
Sounds like a cool story. Where do we even begin with that?
Well, there's this guy, Raphael Dubois, French physiologist back in the 1880s. He was studying click beetles. You know those beetles that click?
Oh, yeah, the ones that kind of jump too.
Yeah, those guys. Well, they glow too. And Dubois, he had this breakthrough. He was grinding up beetle parts, doing these experiments with hot and cold water. And he figured out there had to be two parts to this glowing thing, one that could survive heat, one that couldn't. He called them luciferin and luciferase.
Aha! So that's where those names come from. Pretty clever.
Right. He laid the groundwork for everything we know about bioluminescence.
Amazing. But how do we get from beetles to glowing mushrooms?
So later, scientists tried using Dubois' method on fungi, right? Figure out their fuel and spark. But it was tough. It took like years to solve.
So who were the big names trying to crack the fungal code?
Well, there's this mycologist, Denis Desjardins, and a chemist, Cassius Stavani. They were determined to figure it out. Like back in 2005, they did tons of experiments, all kinds of fungi, using that hot and cold method.
And what they find, was it what they expected?
This is interesting. They found that all these different fungi, they seem to be using the same fuel, the same catalyst. Like maybe bioluminescence and fungi only evolved once, way back, and then just stuck around in all these different species.
Wow, like a family legacy, but with glowing. That's incredible. But I'm guessing they weren't alone in this, right?
You got it. Competition. There was this lab in Russia led by Ilya Yampolsky. They were hot on the trail, too. A real scientific race.
Okay, now this is getting good. Two teams, both top-notch, trying to solve this mystery. What happened next?
So Stefanetti, he realized the Russians might be ahead. He reached out to Yampolsky, thinking maybe they should team up. But turns out the Russian team already had the answer. They just hadn't, like, published it yet.
Oh man, the suspense. So what was it? What makes these mushrooms glow?
So it's this compound called hispidin. It also works as an antioxidant. And here's the kicker. Hispidin isn't just in fungi. It's in plants, too.
Wait, hold on. You're saying the same stuff that makes those mushrooms glow, it's in, like, regular plants?
Yep, Stefanani, he even said later, like he was looking for this molecule for 15 years, and it was right outside his window the whole time.
Wow, talk about hidden in plain sight. So what happened with the two teams? Did they end up working together?
They did. Once they knew, Stefanetti and Yampolsky, they joined forces. Together, they mapped out the whole, like, biochemical pathway for how fungi make light. They even named the fungal catalyst luz, which means light in Portuguese. Pretty fitting, right?
That's awesome. See, this is why collaboration is so cool. But gotta ask, where do the glowing petunias come in? How did we get from, like, mushrooms in the woods to a plant you can buy online?
So Stevani, he had this idea, right? Since plants already have the stuff that makes hispidin, Could you, like, engineer them to glow?
Wow, that's a big leap. Did he actually try it?
Well, funny thing is, Yampolsky was already on it. A synthetic biologist on their team, Karen Sarkisian, he was working on that exact thing.
No way. So both teams had the same idea independently. That's wild. And does it work? Did they make a glowing plant?
Oh yeah, it worked. Sarkisian's team, they took the genes for bioluminescence from a specific fungus, Neonothopanus nambi it's called, they put them into a tobacco plant.
Okay, so like, did it light up?
It did. The whole plant glowed, not just the leaves. Shoots, buds, flowers, even the roots. It was really something.
That's incredible. Okay, but how do you even like take genes from a fungus and put them into a plant? That sounds like, I don't know, super advanced.
Sarkisian explained it pretty well. He said plants and fungi, they kind of speak the same biochemical language. So moving that whole pathway, the chemical reactions for the light, it was surprisingly pretty easy.
So it's like translating a book, not writing a whole new one.
Perfect analogy. And they didn't stop there. They engineered other plants to glow, too. Chrysanthemums, poplars, this little plant called Arabidopsis, and, of course, the petunia.
So that glowing petunia, the one that started this whole thing, it's for real. You can buy it, put it on your windowsill. Crazy.
Oh, yeah, it's real. The USDA even approved it. A company called Light Bio makes them. They said, like, these plants are safe, no environmental risk.
Right. Brings us back to that writer, the one who bought the petunia. They were curious, just like us. Is it just a cool thing, or is there something more to it? What did they find out?
Well, they noticed the glow was kind of subtle, dimmer than a candle. And they wondered, what if these genes got out into the wild? Could that be bad for the ecosystem?
Yeah, that's a good question. Did they find anything about that?
So it turns out there aren't any truly wild petunias in the U.S. The ones we see are all hybrids, already mixes of different kinds. And this expert, Elsa Youngstead, she studies pollination. She said these hybrids, they haven't shown any signs of becoming invasive.
Okay, so no glowing petunia takeover. That's good. But it still makes you wonder, why even make a plant glow? Is it just for kicks, or is there, like, a bigger point?
That's exactly what the writer was wrestling with. And in the end, they had this realization, kind of a shift in perspective. It wasn't just about the petunia itself, It was about the whole journey, the whole story of how it got there. All that science, the history, the collaboration. That's what made it really cool.
It's like that saying, it's not the destination, it's the journey. And in this case, the journey is telling us something about like how everything's connected, right? This little flower, it represents all this amazing science, all these brilliant minds working together. It's pretty inspiring when you think about it.
Totally. And it all started with like one person's curiosity. They saw this weird glowing plant and just had to know more. That's what's so awesome about curiosity. It can lead to some seriously amazing discoveries.
I hear you. It makes you think, what else is out there, right? What other ordinary things have these incredible stories behind them? So would you have a glowing petunia? I'm not sure how I feel about it, honestly.
I think it's bigger than just like personal taste. For me, it's more about appreciating how we got here. The science, the collaboration, the fact that we can even do this kind of stuff. It's incredible.
That's a good point. It's not just a novelty. It's like a sign of how far we've come. But with that comes some big questions, right? How do we use this knowledge responsibly?
Exactly. We're uncovering all these secrets of nature like bioluminescence, but we got to be careful, right? It's not just about what we can do. It's about what we should do.
That's a good takeaway. This deep dive, I took us from the ocean with all those glowing creatures to the chemistry of mushrooms, to a lab in Russia, and finally to a little petunia on a windowsill. What a trip.
Right. And that's just one little corner of all the knowledge out there. There's so much more to discover, so many more connections to make. It's exciting.
It really is. So here's the thought for everyone listening. What else could we do with bioluminescence? I mean, imagine glowing trees lighting up our cities, or using those bacteria to like detect pollution in the water. The possibilities are endless.
That's what I love about science. It's not just about finding answers. It's about asking new questions, coming up with new ideas. Who knows what amazing stuff we'll discover next?